You ever been scrolling online and just stopped in your tracks by some stunning, totally bizarre, or beautiful image, and then you realize it was made by an AI? Yeah, from these wild fantasy landscapes to photorealistic portraits, this tech is just everywhere. But it begs the question, how on earth is any of this even possible?
I mean, it really does feel like magic, doesn't it? You type something like an astronaut riding a horse on the moon into a tool like Midjourney or Dolly, and bam, a few seconds later, you've got art. But how does that actually work? How does a computer learn to be an artist? Well, that's the big mystery we're going to unpack right now.
So, the short answer is it's not magic. It's actually a fascinating technological journey that has evolved so quickly. We're going to look at the three major breakthroughs that took computers from just, seeing an image to creating completely new ones from scratch. Think about it. Before an AI can paint a cat, it has to understand the very essence of catness. And that means it has to analyze millions and millions of images to learn the basic patterns of our visual world. So the very first step on this whole journey wasn't even about being creative. It was all about learning to make a perfect copy. All right, so let's meet our first model. Think of it as an AI apprentice. It's called an autoencoder, and you'll often hear about a version of it called a VAE. Its first job, its only job, is to learn how to perfectly copy an image, but the way it learns is where the real genius is. And here's the key. It's all about this two-step process. First, you have the encoder part. It takes a full-size image and squeezes all of its essential information down into this tiny, compact code. I mean, think of it like a super condensed summary or a zip file of the image, but it's just a string of numbers. Then, the decoder part tries to rebuild the original image using only that compressed code. Okay, so take a look at this. It really shows you what's happening. If you follow the arrows from the right, the AI takes an original image, in this case, a pair of pants. Then, it encodes it, squishing it down to just two numbers, which becomes that single black dot on the graph in the middle. From just that one point, it then decodes it, trying to draw the pants all over again. It does this millions of times until it gets incredibly good at capturing the essence of an image. And this right here is where the magic starts to happen. That map of dots you see? That's called the latent space. All the images of pants get clustered in one area. All the shirts end up in another. And once the AI has this map, it can start to navigate the empty spaces between the dots to generate totally new hybrid designs. A shirt that's kind of like a jacket, or pants that are somewhere between jeans and slacks. This was the very first glimmer of true AI creativity. Okay, so that's pretty cool, but there was a big problem. The reconstructed images, they were often blurry, kind of fuzzy, and lacked detail. To solve this, a completely new approach popped up in 2014, one based not on copying, but on competition. This was a high-stakes game between two competing AIs. This is the idea behind generative adversarial networks, or GANs. Get this, on one side you've got the generator. Think of it like an art forger. It takes random digital noise and tries to sculpt it into an image that looks totally real. And on the other side, you've got the discriminator. It's the art critic. Its only job is to look at an image and say, is this a real photo from the training data, or is it a fake from the forger? And the way they learn is just this constant back-and-forth battle. The generator makes a fake. The discriminator judges it. If the discriminator spots the fake, the generator learns from its mistake and has to try something new. But if the generator actually fools the critic, then the critic has to get better at spotting fakes. This relentless cycle forces both AIs to get smarter and smarter together, incredibly fast. And wow, the results were just explosive. The introduction of GANs in 2014 kicked off this sort of Cambrian explosion in AI image generation. Within just a few years, we went from these blurry, abstract blobs to these stunningly photorealistic faces of people who don't even exist. And eventually, all this progress laid the groundwork for the text-to-image models that we use today. Okay, so GANs were a huge leap forward, but that brings us to what's really running the show today. Diffusion models. Now, if a GAN is like a forger trying to fool a critic, a diffusion model is more like a sculptor. It sees the masterpiece that's already hidden inside a block of marble, or in this case, a screen full of digital static. Now, the way these things learn is kind of backward, but it's absolutely brilliant. During its training, the AI starts with a perfect, crystal clear image from its massive data set. And then it just destroys it.
on purpose. It adds a little bit of digital noise, a little bit of static, then a little more and a little more over hundreds of steps until the original image is completely lost in a sea of random pixels. And it just does this over and over, carefully studying how an image dissolves into total chaos. Because here's the secret sauce. The AI isn't learning how to add noise, it's meticulously learning how to reverse that process. It learns how to look at a noisy image and predict exactly what tiny bit of noise it needs to remove to make it just a little bit clearer. So when you ask it to generate an image, it starts with pure random static, and then step by step, it masterfully carves away the noise, revealing the coherent, beautiful image that was hidden inside all along. So, okay, let's take a breath and bring this all together. These three core ideas, the apprentice, the rivalry, and the sculptor, these are pretty much the pillars holding up this whole AI art revolution. So here's the cheat sheet, right? Autoencoders, our little apprentices, are fantastic for compressing data and finding its core essence. GANs, with that competitive forger and critic dynamic, are incredible at producing a huge variety of high-quality images. And diffusion models, our sculptors with their meticulous denoising process, are the current champs for creating those breathtakingly realistic and detailed images we see everywhere. And, the big names you've heard of, DALL-E, Midjourney, Stable Diffusion, they are all these super sophisticated systems that are built directly on these principles. They primarily use that diffusion sculpting process we just talked about, guided by an amazing understanding of language to turn your words into art. I mean, from learning to copy, to competing in a game, to sculpting art from chaos, machines have developed this truly remarkable new ability. It's an incredibly powerful tool, but it also leaves us with a huge, fascinating question for the future. If a machine can be an artist, what does that change about human creativity itself?